Hi, Sayuri. Welcome to this morning's workshop. You're the first one here, so well done. Good to see you. Let's see if anyone else is arriving. It's still about 3 minutes before 10. So we'll just wait for more people to come and then we will kick off. So Yuri, where are you in South Africa? Mpumalanga, okay. I bet it's nice and warm there. Here in Cape Town where I am, it's been raining and it's been pretty miserable. So what's the weather like there in Mpumalanga? Bit chilly, okay. Right, we've got some more people arriving. What else is here? Looks like Karabu's in the waiting room. Karabu's also one of our regulars, so here she is. Hi, Karabu. Morning, Danao. Good to see you again. You're also a regular. Hi, Benedict and Jaden. All the familiar names and faces. I hope you guys are ready for this. It's going to be a busy 3 hours. We've got lots to get through, with trigonometry being such a big part of your paper. So while we're waiting for some more people to arrive, can you put for me just in the chat how you feel about trigonometry in general? If you had to give yourself a rating out of 10 with trigonometry overall for the whole section, what would you rate yourself? I can just put it out 2, 5. Hi, Sola. I didn't see you into the room. Saki, 6 out of 10. Hi, Saki. 4 out of 10. Oops, what have I done here? Writing all over my board here. Three and a half, says Jaden. Well, hopefully after today, that rating will improve at least a little bit. Nola. Welcome, Nola. Caitlin. Okay, I'm gonna wait till about 5 past and then we'll start. As people jump on, we'll get going. Those of you who've just joined, we are giving ourselves a rating out of 10 for trigonometry. So if you also want to put down your rating, Caitlin and Nala, overall, how you think you do in trigonometry and how you feel about it. Five out of 10. Personally, don't like trig. Okay, I'm just going to wait 1 more minute. What you can do in the meantime as well is, I'm sure you've got notes and some paper and pen and paper ready there. But if you could maybe have a loose piece of paper, a blank one, just like this. It can be lined or just blank, doesn't matter. But if you could have that sort of next to you, with your pens and pencils and all of that. Calculator, just check you've got your calculator. We're going to need that. And if you've got a textbook, that's also useful. You can keep that handy as well. Because, yes, I think trigonometry in general is quite a big section, and there's so much to cover, and it can be quite daunting. So what the aim of today is going to be to cover these parts of trigonometry, so reduction formula, which is what you learned in grade 11. And we're going to start there because we can't really tackle the grade 12 stuff if we're not comfortable with those reductions. Then, because compound and double angles build on from there, we're going to do that next. And then we're going to start looking at sort of how this is asked and how that gets asked in a question where you have to draw a sketch and you can't use your calculator to find the answer. We're going to look at identities and at equations. Now, the reason I'm focusing on these, and you might wonder, where's the 2D trigonometry, like sine rule, area rule, cos rule, and where's the 3D trigonometry? These things really, it's very hard to tackle the 2D trig and the 3D trig if these things that we're going to do today is not in place. And the same with the graphs. So if you can do equations, then you can probably answer the most of the graph marks as well. So the bulk of the trigonometry marks sit in these sections. Okay. So today also ask questions. Okay. So there's not a lot of time left before your exam. I think it's about 2 weeks. So now is the chance. Okay. There will likely not be more chances for you to clear up any confusion or things you don't understand. Now is the chance. So make sure that you ask, stop me, don't feel bad to interrupt me, put it in the chat. If I don't see it, Tula will see it. Tula is our mentor, by the way. Sorry, Tula, I haven't even welcomed you. But he's here with us today as our mentor to help you with the chat and if there's any technical difficulties. And so put it in the chat, unmute yourself, shout out, let me know if I need to stop or say something again. Okay, because we want you strong for this section when you get there on the, I think it's the 8th of November. Okay, so why do you need this piece of paper? So what I want you to do is to fold it in half and then fold it in half again. And that should give you, if you look at mine, there's 4 blocks on this side and another 4 blocks on the other side. And this is basically going to be like your cheat sheet, because in trigonometry, there's a lot of rules and things you need to know and remember in order to work quickly through the questions. And if it's just all floating around in your head and you're not clear, today we're going to make, through the course of this workshop, you're also going to be making yourself a cheat sheet where you write down the important things you need to know. Okay, so if you like colors and highlighters and stuff, go mad and make it as bright, because you have to use it. So make it as bright and appealing as you want. You can start by putting at the top of the page trigonometry, so that you know this is your trigonometry cheat sheet. And we're going to kick off with our grade 11 trigonometry reductions. Are we all ready? Please give me a thumbs up in the chat if you're ready. Right. Saki says ready. Okay. Good stuff. Nice, guys. Ready. Awesome. Okay. So it's 3 hours. We're all going to take a break or two, okay, because it is a long time. Yeah, let's go. Okay, so let's start with grade 11. And this is maybe the first of your 4 blocks that you want to populate with notes and things. And you don't have to rush to try and take down my notes or anything. But the reduction formula, what that is about is the cost diagram, basically. So you can draw your 4 quadrants, and you can write down the cost rule and the different quadrants, 1, 2, 3, and 4. And remember that in each of those quadrants, the cost rule tells us where the different trig ratios are positive and negative. Okay, so on my one that I've got over here, sine is positive in the first and the second, cos is positive in 1 and 4, and tan is positive in 1 and 3. So if you look at my one, that is indicated over here. That's the different signs. Okay, and that is the same as cost. Cost, or all stations to Cape Town. So if we put our 4 quadrants down like this, then this is quadrant 1, 2, 3, and 4. And this quadrant is just the theta quadrant or the x quadrant. So any angle that falls in that first quadrant is just going to be an acute angle, or is going to be defined by 90 minus theta. Now, how the whole cost diagram works, if I can just quickly revise that, is this is an arm that I've just drawn in here, and it's it can move and it can rotate through 360 degrees, and as it rotates, it is going to make an angle in each of these 4 quadrants. Okay, with trigonometry also, funny enough, we rotate anti-clockwise, so we don't go the other way around unless we are doing negative angles, but if we are doing positive angles, we're going this way around. So if this arm rotates and theta is in the first quadrant, then that's where it will be, and all our trig ratios are positive, so that's where the A comes in. You might know cost, you might know all stations to Cape Town, etc. Now, if you carry on rotating this arm and you stop in this quadrant, then this is the 180-degree minus theta quadrant. And if you carry on and you end up in this quadrant and you keep rotating like that, this is the 180 plus theta quadrant. And if you go here, now you're in the 360 minus theta. So right now, you should be very clear on the different quadrants and how they are named. That 90 minus, the 180 minus, the 180 plus, and the 360 minus. That's very important. And you must know your cost or all stations to Cape Town, or the different ways your teachers might have taught you to remember where the different trig ratios are positive and negative. And if you are just remembering the positive ones, it means that if sine, for instance, is positive in the first and the second, then it is negative by implication. The sine ratio is negative in the third and the fourth quadrant. So you just remember the positive where it's positive, because then by implication it is negative in the other quadrants. Okay. How are we doing with that so far? That's just a brief recap of reduction formula and how the quadrants are named and where sine, cos, and tan are positive. How are we doing with that? Just give me a thumbs up or a thumbs down, because this is the first very important thing that must go on your cheat sheet and that you need to know very, very well. Your focus should be on learning the quadrants and learning where the sine and the cos and the tan are positive, so that you don't sit in the exam wondering about it. Okay, it must come fairly quickly. So if I can compare it to like when you were in grade 1, you had to learn that 3 plus 1, for instance, is 4, and 1 plus 1 is 2. Now you know that. And it's the same now in grade 12. You must know, like at the tips of your fingers, where the different trig ratios are positive and negative. So you can start there with trigonometry and make it easier for yourself by learning your cast diagram. So that would be the first thing I would do. If you said earlier, you know, you feel about a 2 out of 10, a 3 out of 10 about trigonometry, this is where you can start to start feeling a bit more positive about it. Okay, now the next thing we must know is where you are when you are on the Cartesian plane, and we are talking about that. So I'm going to say that this is actually the first thing, and then this is the second thing. You obviously need to know SOHCAHTOA, right? Opposite over adjacent for tan, adjacent over hypotenuse for cos, opposite over hypotenuse for sine. And that is in a 90-degree triangle. Okay, so today we're just going to focus on 90-degree triangles. Don't worry so much about non-90-degree triangles, because that comes in with your sine and cosine rule. What we're doing today is just 90-degree triangles. So you need to know that which sine, cos, and tan. SOHCAHTOA, or what is the one, the old hen something. There's lots of different ways to remember SOHCAHTOA. But more importantly, when you're on the Cartesian plane, you have to call those sides, instead of opposite, hypotenuse, and adjacent, you have to call them by X, Y, and R. So that's what this second block, or actually my first block, is about. This one here. That is important. And knowing what the sides are called on the Cartesian plane and what they are called when you are just in a triangle. And you're more than welcome to jot down this little diagram here, because that shows you where the X and the Y and the R is. R is always the hypotenuse side, and the X and the Y will make up the adjacent and the opposite sides when you're on the Cartesian plane. Okay, right. So that's reduction formula and the Cartesian plane and all of that. Now, the next thing that goes hand in hand with reduction formula is negative angles. Now, negative angles is for instance, sine of negative theta, cos of negative theta, and tan of negative theta. So how that works, remember what I said in trigonometry, we rotate, when we are talking about positive angles, we rotate anti-clockwise. But when we rotate in the other direction, so if this is my Cartesian plane, and now that arm that I was talking about doesn't rotate that way, but it rotates that way, then it's going to land up in this quadrant here, and that is actually going to be a negative angle. So that is, for those of you who also do physics, it might help you to understand this better, that in this case, the negative has to do with the direction in which you are going. So if you're rotating anti-clockwise or clockwise, then that is a negative angle. That's all the negative angle really means, is rotating in the clockwise direction. So if you didn't know that before, if these negative angles didn't make sense to you, just think of it as rotating in a clockwise direction. So then you are going to end up sort of, okay, so you're going to end up here, and it's really just about the direction you are going into. That's it. You're just going to keep rotating in the opposite direction. So now think about it, and I'm going to take this away. Now, if you know your course diagram well, then the negative angles make a bit more sense, because sine of a negative angle, that means the arm, that terminal arm, has now rotated into this quadrant here. So that is actually negative theta. Negative theta is here. Now, we know from cos, sine in this quadrant is negative, right? So instead of trying to remember it, you can reason it out for yourself if you know the cos diagram really well. Then it's quite easy to understand why sine of a negative angle is negative sine theta. And cos of a negative angle, that would be positive, right? Because cos in the fourth quadrant where this negative angle is sitting, cos is actually positive there. And tan is negative because tan in this fourth quadrant is also actually negative. Okay, sorry for all those interruptions. I'm actually just quickly going to go and switch off these notifications that I'm getting so that we can stop. It's like someone knocking on a door. Let me just do that quickly while you guys mull over what all of this means. Okay, there we go. That should stop all that noise now. Okay, so that's negative angles. That's like a subsection of your reduction formula in your cos diagram. Okay. Special angles. Special angles are these triangles, and that they must definitely go onto your cheat sheet. Your special angles. These ones here. And why do we call them special angles? Special angles because, so there they are. These you do without a calculator. Okay, now this is probably the next thing the next important thing, Shane, Zulihle, thank you for letting us know. You're at school, okay. But yeah, you're welcome to watch the recording later, okay. Thanks, Zulihle. Right, so as I was saying, this means, and I'm going to write it here in big red letters, no calculator. And you've got to know, this is the next part that's going to help you do better at trigonometry. Know which angles are special. 30, 60, 45. Those are special. And you have to, in the exam, calculate them using your triangles and not your calculator. Okay, so these ones here and these ones here. Okay. I've seen many students in grade 12 not know their special angles, and then they use their calculators, and in the exam it is a breakdown. I think if you've been in my class before, I've explained what a breakdown is. Breakdown is not great. A breakdown is when you don't get any marks for any of your working because you made a serious conceptual error. And that conceptual error, sometimes I've seen people make, is by using their calculator to do the special angles. And then if it's like 5 more questions, you get nothing. Okay. So know your special angles, know your triangles and how to set them up. Again, you can't walk in the exam wondering, where does the 60-degree go? Where does the 30-degree go in my triangle over here? Where does the root 3 go? This you have to know. Okay. And you see why you're making a cheat sheet, because there are many things in trigonometry you have to just know and study. Okay. So we're actually going to do some examples just now. So know your special angles. And the last one, the last rule that I also see lots of people forget about is the co-ratio rule. Now, the co-ratio rule says, if you are in the first quadrant, or if the angle is written as 90 minus theta, then immediately you must know, if it's sine of 90 minus theta, I must change that to cos. If it's cos of 90 minus theta, I must change that to sine. Now, why is that? Okay, and we're going to do a quick example just using our calculator. I want you to, on your calculator, do, just put in on your calculator, sine of 50 degrees. Sine of 50 degrees. Okay, and I get 0.766 something. Now put into your calculator cos of 40 degrees. And what do you see? It's the same. But what about these two angles? What do you notice about them? You should notice that they add up to 90 degrees. And that is why the co-ratio rule works, because sine of 90 minus will be the same as cos of that angle. So you change from sine to cos and from cos to sine. And you can you can test some more examples. You can do sine 20 and cos 70, and you can do cos of 10 degrees and sine of 80 degrees, and see if you get the same thing on your calculator. And you will, because if the angles add up to 90 degrees, sine and cos are the same thing. So that's why we change from cos to sine and sine to cos. Okay, I've done enough talking. I'm going to hand over to you now, and I want you to just do part A, where I've written here in blue, expresses ratios of acute angles. Just do those 3 questions for me now, and in about 5 minutes, we are going to look at it together. Okay, so no calculator or anything. You are express the ratios as acute angles. Just give it a shot, and we'll go through it together. Put a thumbs up when you are done, please, so that I know. For those of you watching on the live stream, we are doing part A, question A, B, C, expressing the ratios of acute angles. So sine of 315. I wonder if someone's ready to start us off with that one. Who can I ask? Put your hand up if you're ready to offer an answer for sine 315 degrees. Nice. Let's hear Benedict. Benedict, was that by accident? Yes, so you reduced it. How did you reduce it? That's exactly what we're doing. We're reducing it from a non-acute angle to an acute angle. You said, perfect, sine of 360 minus 315. Okay, so that gives you sine of 45. And then what do you notice about 45? 45 is a special angle. So we need to go back up here to where our special angle is and use our triangle to find out what sine of 45 is. So you don't stop at the sine 45 because remember we reduce as far as possible. So we simplify as far as possible. So sine 45, we're going to do, here's 45, and there's opposite over hypotenuse, so that's 1 over root 2. Okay, who got that? Please give a thumbs up if you got that. Okay, guys, if you didn't get that, you better be asking a question, please, so that we can get you sorted for this.
Ma'am?
Yes.
Is it fine if I said 360 minus 45 and then I said sine? Is that?
Yes, that's fine. And Chad, you're right. We should have said that this is negative. Why? Because sine in the fourth quadrant is negative. Well spotted. Thank you, Chad. Anyone else who has a question? We've got to get these right, guys. You've got to be able to reduce and then use as a special angle. Timothy, did you get this?
Ma'am?
Yes, who's speaking to me? Sorry, let me just see.
Karabu.
Karabu, yes.
Yes, ma'am. So I just want to know, after you find the sun 45, you have to go to the, well, know that it's a half over, 1 over the square root of 2.
That's it. You have to do that.
Okay.
This is a special angle.
Okay, ma'am.
Yeah, don't stop at the sine 45. You have to go all the way.
Okay, ma'am.
Okay, Timothy, got here a bit late. Okay, no stress. Anyone else? Okay, let's see if we can get the next one right together. Okay, who wants to offer an answer? Can I write this out? I'll give you a shot to quickly re-look your answer after we did this first one. Let's see who can put a hand up and help us do question B. Cos of 150. Jaden, how are you feeling? Can you do that one for us? Cos 150.
Okay, I said cos 180 minus 150 is cos 30, and that is square root of 3 over 2.
Okay, what quadrant is 150 in?
150 is in the second quadrant.
So
which
cos in
sign
this
is negative.
cos is negative. That's right. And then negative cos 30, we go back to our special angles over here because 30 is also a special angle. And we go adjacent over hypotenuse. There's 30. Oops. There's 30. And there's adjacent over hypotenuse. So it's root 3 over 2. Okay, who got that one? Hands up, please. Thumbs up if you got that one right. Great.
Ma'am?
Yes.
I want to know why it doesn't stay a minus.
Sorry, it's because I left it out. It definitely stays a minus.
It's stressing for a bit.
No. The minus doesn't then disappear again. Okay. Good. Last one. Let's do tan 240. Who's going to do that one for us? Deneo, do you want to try? Tan 240.
Ma'am,
Yes.
I said 180 minus 240, which gave me 1060. So
Okay, now let's work together here. So 240, this is the first thing you must ask yourself. In which quadrant will 240 degrees be?
on the third quadrant.
It's in the third quadrant. And all the angles in the third quadrant, we write them as 180 plus a number. So what must I add to 180 to get 240?
60.
Say that again.
60, ma'am.
That's it. So 180 plus 60 is going to give me 240 because now I'm in the third quadrant. Is tan positive or negative in the third quadrant?
It's positive.
It's positive. So we can just write tan of 60. Is 60 a special angle?
Yes, ma'am. So the
Yes.
square root 3.
So we go here and we're doing tan. So it's TOA opposite over adjacent. So it's square root of 3. Okay. You got that one. Let's see some thumbs up, thumbs down.
Ma'am,
Yes, Karabu.
ma'am, why did you say 360 minus 240? Is that wrong?
Yeah, because 240 degrees, if you look at your diagram, your cast diagram,
Yes.
240 degrees will fall in the third quadrant. You can't say that it's 360 minus because that is the fourth quadrant. Does that make sense?
Yes, ma'am. Thank
Okay,
you.
so if we look at this first one, that was sine 315, that's in the fourth quadrant. So all the angles that I have in that quadrant, I can write as 360 minus a number. So we said that's 45 degrees, and sine is negative in that. So if I can summarize it, you need to basically say quadrant. What quadrant is your angle in? And then rewrite it. And then choose whether your trig ratio is positive or negative, and simplify if it's special. Okay, so that's how we do our reductions.
Okay, ma'am. Thank you.
Okay, let me just read some messages here. Okay, I've got some thumbs up. Thumbs up. Excellent. Okay, now, this is the other way it gets asked. You've probably seen these kinds of questions, right? I'm going to do the first one with you. So let's follow all together. But be ready. I'm going to call on people to tell me if the ratios are positive or negative, and how we must rewrite them. Okay. So we start with the first one, sine of 180 minus x. 180 minus x is which quadrant?
Second.
Second quadrant. And sine in the second quadrant is positive. Okay, so I can write that as sine of x. Cos of 180 minus x. 180 minus x, we've said, is the second quadrant. Cos in the second quadrant is negative. So I write that as cos of x. I like to put stuff in brackets because it's less confusing to me. But if you, yeah, I would actually really recommend whatever you change, put it in a bracket. Then tan of 180 plus x. What quadrant is 180 plus x? Put it in the chat if you know, or you can just unmute and shout out. Don't be shy. Third quadrant, yes. And tan in the third quadrant is positive or negative? Positive. There we go. And we just write it as tan of x. Here's sine of negative x. Sine of negative x, what did we do with that? That falls under what? A negative angle. And what did we say? Sine of a negative angle must be negative. Negative sine x. And then cos of 360 minus x. So 360 minus x, which quadrant? Which quadrant is that? Shout out or put in the chat. 4, it's the fourth quadrant. And cos in the fourth quadrant is positive. Okay, so do you see that when we do the reductions, we change the sign based on the quadrant, and the 180 and the 360 just fall away, and we have x's. Okay, now we're going to we've got a fraction, and we're going to cross cancel. So this can cancel with that, and that can cancel with that. Now I have a negative over a negative, so the whole fraction will be positive, and I'm left with tan of x. Now for this mark allocation, it's really nice, right? Because it's 8 marks, and you get literally a mark for each thing you change correctly. So that's a mark, that one, that one, that one, that one. And for then cancelling, I think that's another mark, and then your answers maybe 2 marks. Yeah, probably something like that. So that's 8 marks. Very nice. Okay, so do you see that if you practice these, you can do really well? Okay, let's go to 8.2. I'm going to give you 2 minutes to try this one on your own. I'm going to be quiet. When you're ready, please give a thumbs up. At the same time, don't hesitate to ask a question while you are doing it. Okay, right. Let's have a look. Now, sine of 90 minus theta. Who can tell us what we are going to change that to?
I think it's cos theta, ma'am.
Cos theta. Well done, Timothy. Yes. Cos theta, because the 90 minus quadrant is the where you have to apply that co-function rule. So that is cos theta. Tan of 180 minus theta. Timothy, while you're here, tell us what that's going to be.
I think it's tan theta.
Tan theta. Is tan positive or negative in the second quadrant?
The second quadrant, tan is negative.
It's negative.
Yes.
Okay. And then cos of minus theta?
Negative cos theta.
So remember, the negative angle is actually in this fourth quadrant.
Oh, cos is positive in the fourth quadrant.
Yes. That's it. Cos of theta. Okay, last one. Sine 180 plus theta.
Negative sine theta.
Excellent. Okay. There we go. Right. Who got all of those right? Put a thumbs up if you got all your reductions correctly. You knew what to do with the 90 degrees. You knew what to do with the negative. Oh, yay. Well done, guys. Yay. Awesome. Okay. So now we are going to cancel. And what we are left with is minus tan over minus sine. But what are we going to do here? Minus over a minus is a positive, so we can drop the minuses. What are we going to do here with the tan? What are we going to change it to? It's not something we've talked about today, but it's something, yes, change it to sine over cos. Well done, Caitlin. Sine theta over cos theta. We change the tan to that. Okay, that is something that should go on your cheat sheet if you didn't know this. Tan theta changes to sine theta over cos theta when you are simplifying and doing identities and stuff like that. That must definitely be on your cheat sheet. Okay. Okay, so now we've got sine theta over cos theta. Okay, so we are dividing sine theta over cos theta by sine theta over 1. So why did you learn back in grade 7 about dividing a fraction? It's the same as times by the inverse. So you do a little tip and times thing there, and you get that. And final answer is 1 over cos theta. I would have actually thought this one was worth the 8 marks more than the other one. But anyway. Okay, who got final answers? 1 over cos? 1 over cos. Okay, so if you missed out on this part here where you had to change the sine, the tan to sine over cos, then maybe you got about 2/3 of the way. Well done, Sola. Yeah, it looks like. And Sayuri, well done. Excellent. Okay, so the first block of your cheat sheet should be filled. Well, maybe you didn't get a chance to write it all, but you can definitely spend some time later making sure cos diagram, negative angles, special angles, and co-ratios, that grade 11 stuff you learned, that is all, believe it or not, still grade 11. That stuff is all there. Okay. Now we're going to go on to the grade 12 stuff. And like I said earlier, this builds on what you learned with the reduction formula. Okay. So you learned in grade 12, your new trigonometry is the compound angles and the double angles. So I'm just going to first start by doing the compound angles. Compound angles means it's an angle made up of 2 parts. For instance, we can say 75 degrees. You can write that as 60 degrees plus 15 degrees. That's a compound angle. You can write it as 35 and 40, for instance. 35 plus 40 is going to give you 75. You can also write it as 100 minus 25. Those are all compound angles. Okay. Now the compound angles, there are 4 formulae for the compound angles. And if you look at it, and it just completely hurts your eyes to look at the formula, then I suggest you write down this little summary here of the compound angles. Just ignore the double angles for now. We'll talk about them in a second. But just write down sine A plus B will be sine A cos B plus cos A sine B. Okay, so do you see how the signs work? If it's A plus B, then in the expansion, it's A plus, it's a plus. If it's sine A minus B, then it's a minus. So the order here follows that order. But for cos, it's the other way around. If it's plus, then in the expansion, it becomes a minus. And if it's a minus, it's a plus in the expansion. Okay, now maybe when you see sine 45 plus 10, because we're so used to learning about multiplying brackets, you want to do this. You want to say sine 45 plus sine 10, but that is wrong. Okay, we don't do that. We don't put the sign into the bracket. I've seen so many people do it. No, we need to apply this whole long rule here and expand it using the rule. Luckily, you don't have to remember it. It is on your formula sheet. Okay, so I'm actually going to rub this out so we don't ever do that again. We just use the formula to expand it. Okay, and we're going to practice expanding and because it works both ways. You can expand and simplify with the compound angles. Now, we're not going to have time to do that today, but somewhere in your textbook or from your teacher's notes, you should have the proofs of the compound and double angles, and these are examinable. So just check your textbook for that. Okay, this is like study work, book work. It's just, you just have to study it. It's not, we won't have time to go over it. It's just literally proofs that you have to study. Don't leave it out. It's probably worth about 4 or 5 marks for something you just have to study. So it's definitely important. Okay, let's start with this first example. So without the use of a calculator, determine the value of cos 24 cos 36 minus sine 24 sine 36. Now, because you're not using a calculator, there's really nothing you can do just by looking at it. But if you look at it and you realize the pattern, okay, so this is actually cos of angle A, cos of angle B, minus sine of angle A, sine of angle B. And that is cos A minus, no, plus B. Okay, it's this one here. So you can rewrite that as cos A plus B. That whole long expansion can be made shorter by just realizing, okay, well, it's actually this the cos expansion, the cos rule for a compound angle, cos A minus B. Okay, so what are we going to do? Oops, I shouldn't be pressing there. I should be pressing here. So you can go straight to cos of 24 plus 34, which gives me cos of 60. There's my special angle again. And we don't stop there. We use our triangle, and that will be a half. Okay, any questions about that? Because this next one, number 2, you're going to do on your own. Give me a thumbs up if that makes sense, please. If it doesn't, please shout so that we can work through it. Makes sense. Excellent. Okay, let's do number 2. Take a moment to do number 2. Those on the live stream, I'll ask you in a minute or so as well to tell us if you got that same answer. Tula, will you check if anyone is watching on the live stream and if they're giving thumbs up or thumbs down? Okay, Timothy says he thinks he's got it. Good. Anyone else ready? Nola, you're very quiet. Jaden says he thinks he's got it. Silindile. Right, Silindile, are you going to help us do this one?
Yes.
Great, go for it.
I said sine 67 plus 83 degrees is equals to sine 150. And then I said sine 180 minus 150 is sine 30, which gave me a half.
Excellent. Yay. Well done, Silindile.
Thank you.
Right, so we see that this is sine A cos B cos A sine B. So that must be sine A plus B. That gives us 150. We must reduce the 150. We get our special angle again, 30. Use our triangle, and then sine 30 is a half. Okay. Right. Let's see if you guys can figure out this one with cos 15. I'm going to give you a hint because the cos 15 is now not written as an expansion or anything, but you actually need to because you can't use a calculator, you have to use your compound angles. So I'm going to give those of you who haven't started it, I see some people have started it already, that's great. I'm going to give you a hint, and you can rewrite the 15 either as cos 45 minus 30 or cos 60 minus 45. So when you see an angle that is not a special angle, because with special angles, we can work them out without calculators, right? So if you see something like 15, that you can write as the compound angle of two special angles, either by plussing it or minusing it. These are all questions that come up in the exam. Cos 45 minus 30 or cos 60 minus 45. You will get the same answer. Right, carry on working on question 3. And for those of you who are fast with this, you can also tackle question 4. If you used cos 45 minus 30 like I did, that formula you're going to use for that is cos A, cos B plus sine A, sine B. There you go. Who got that right so far? For 60 minus 45, it would be the same. Also cos A minus B. Who got that right so far? Please give me a thumbs up. Awesome. Great stuff. From here, it's easy, right? Because these are all special angles. So we can just go use our triangles to use special angles. And I hope I did this right. Let me know if any of these are not what they should be. And then it just gets slightly uncomfortable with these surds at the bottom, at the end. But the surd denominators are the same. You get 2 root 2. So you can just write it as root 3 plus 1 over 2 root 2. Those of you who are doing cos 60 minus 45, you'll get the same. Okay, let's move on to question 4. Are we ready to move on, Matrix, to question 4? Just let me know. Okay, so Sola, can you tell us sine 75? How are we going to write the 75 as a compound angle? Good stuff. Okay, so we can break that 75 up and write it as sine 30 plus 45. And then you grab your formula sheet and you say sine A plus B will be sine A cos B minus cos A sine B. So this is your angle A. If sometimes you get confused which is A and which is B, just label them. Then you can see, oh, that's my A, that's my B, that's my A, that's my B. And then you just literally plug them into the right place. Okay, and then again from here it's easy because we've got all these special angles and we can just write them using our triangles. That's a half. for sine of 30. Cos of 45 is 1 over root 2. Cos of 30, root 3 over 2. And sine 45 is 1 over root 2. And I think our final answer (1 over 2 root 2 minus root 3 over 2 root 2). And that is 1 minus root 3 over 2 root 2. Do not at any stage change it to, there we go, a decimal. Then it's that earth-shattering moment again when it's a breakdown and you lose all your marks. Okay, so these would be nice marks questions. So you'd probably get some marks for breaking it up, for making it 30 and 45. Then for applying the rule, that would probably be 1 or 2 marks, depending on how the memo was done. Yes.
Ma'am, isn't the sign in the middle supposed to be negative? Or, I mean, positive.
Positive.
Let's just look at our rule again. So we are now doing sine 30 plus 45. Oh, you're right. Sorry. There we go. Happy. Is that better? Sine A plus B. Yes, that's right. Should be positive. Here we go. Okay. So you would get a mark for that. For doing your ratios correctly, and then for final answers. So this could easily be 5 or 6 marks. Okay, matrix, let's move on. Are there any questions about the compound angles? So you got to know they're on your formula sheet. You just got to know how to apply them and when to apply them. So when you see, like in question 1, where we had the expansion, you need to know how to put it back into simpler form. And you have to know how to, when it's in simpler form, expand it. And you need to know how to write angles as compound angles with special angles. Those are the things you have to know for compound angles. Any questions about that before we move on to double angles? All good. Can we move on? Give me a thumbs up if we can. Awesome. Excellent. Right. Double angles. So double angles is exactly what it says, a double angle. But with the compound angles, the angles were different. You see what we did with the angles, like a 30 and a 45 and a 67 and an 83, etc. Double angles, it's the same angle. Okay, that's why it's a double angle. So if we start here with sine, I hope this is big enough and you can see it. Let me try and make it a bit bigger. Okay. Right, so sine of 4a. So 4a, what is your double angle? For a, you can write as 2a plus 2a. That is why it's a double angle. And if you look at your double angle rules, that should be going on your cheat sheet. There we go. There's just one for sine of 2x. And then there's 3 expansions for cos of 2x. So cos of a double angle's got 3 expansions, and then sine of a double angle's just got the 1. We'll talk a bit now. It just becomes handy with the identities to know which one to use for cos of 2x. Okay, so sine of 4a is 2a plus 2a. So let's start by applying the double angle for sine, the double angle rule. So that is 2 sine of 2a cos of 2a. Okay, now we can go further and do sine of 2a again, and cos of 2a can also be expanded again, but I'm just going to leave it there for now. Sine of 50, that will be 50 is 2 times 25, right? So your double angle is 2 times 25, so you'll write it as 2 sine 25 cos 25. I find the double angle is often much easier than the compound angles. Then cos of 6a, sorry, I skipped sine of a. So a will be a half a plus a half a. So look out for these ones as well. We're actually doing half of an angle. So this will be 2 sine of a over 2 cos over 2. Cos a over 2. Sorry, this is really small, but okay, cos of 6a, your double angle you see is 6a. So that is 2 times 3a. And for this one, we can use any one of the 3. I'm not going to worry too much about which one, but you can use any one of these 3 here for that. I'm going to choose the easiest one, which is cos squared 3a minus, no. Yeah, cos squared 3a minus 1. And then cos of 80, 80 is 2 times 40. And let's use a different one for the cos, 1 minus 2 sine squared a. 1 minus 2 sine squared 40. You can write it as that. Okay, and then similarly, we can expand and we can make it simpler as well. So here your angle is 3a. So when that is the expansion, so this will be sine of 6 theta. Now there's a little trick here because it says 4 sine x cos x, but you know that the formula says 2 sine x cos x. So what are we doing with that 4? Well, it's just 2 times 2 sine x cos x, which will be 2 sine 2x. You still with me, everybody? We're just using our double angle expansions. Okay, do question 3 and question 4 on your own. And for those of you who are working a bit faster, you can go on to the next little block here. Where it says without a calculator, calculate the value of the following. There's that whole without a calculator thing again. So you know you're either drawing a sketch or using special angles. Okay, who can give me an answer for question 3? Hands up, please. I'm going to have to call on someone then. Who's been quiet?
Ma'am,
Who's Nala? Hi, Nala. Can you give us the answer for question 3?
ma'am, would it be cos 2x?
Okay, so our angle, so let's just go back to the rule. You are applying cos 2x. So do you see, here's our double angle, and then in the expansion, we write it as so then we use half of that double angle. So if it's 2x, then we use x and x. If it's 4x, then we use 2x and 2x. If it's 6, then it's 3 and 3. So here, we're going the other way. It's 2 and 2. So it will actually be cos of, what do you think?
Cos of, so we're doubling the 2.
Yes, that's right.
I'm confused.
So if it's 2x and 2x, then it will be 4x. Like you said, we double the 2. So 2x doubled is 4x.
Okay, I see it, ma'am.
Do you see?
Yes, ma'am. Thank you.
Okay, what do you think of question 4? What are we going to write for question 4? Who can help me? Caitlin, maybe? Is sine squared x minus cos squared x a double angle expansion? Does it fit into any of these ones here? Cos a half x. Look at your formula. Does it follow the pattern of your formula? The formula is cos 2x minus cos squared x minus sine squared, 1 minus 2 sine squared, or 2 cos squared minus 1. Does this fit into that pattern for a double angle? If we divide by minus 1, we can only do that if this was an equation. So this was actually like a trick that I put in there, because this is just sine squared x minus cos squared x. Can't really change that. It's not a double angle formula. But cos squared x minus sine squared x is a double angle formula. Okay, let's have a look at 2 sine 15 cos 15. So it's obviously, do you notice that it's the expansion of the double angle? So what is my angle? Is it 15 or is it something else? Who can help for question 1 in section B? It's sine of 30, that's right. Okay, so whatever you see here, that is what must be doubled. Okay, so it's 15 and 50 gives me 30. And then 30 is obviously now, by this time, we've seen 30 so many times. Okay, it's a half. This next one we're going to multiply out, cos squared 15. This is, be careful when you do this, cos 15 plus sine 15 times by itself. Cos 15 plus sine 15. Okay, so we're going to times this by itself. We are not going to just square cos and square sine, because we are going to miss a middle term if we do that. So it's actually going to be 2 cos 15 sine 15. If you multiply this out, plus sine squared 15. Okay. Do we see any double angles here? Any double expansions? There is definitely a double angle here. And 15. So we can write that as sine of 30 degrees. And what about cos squared 15 plus sine squared 15? What is that equal to? Cos squared plus sine squared from grade 11, you know, it's equal to what? Put it in the chat if you know. Cos squared plus sine squared is equal to 1. That's right. Plus 1. So we're going to do another. Here we go. Sine 30 is a half plus 1. So it's 1.5. So in the green, I highlighted the double angle. Cos squared plus sine squared. Okay, so let's write a little do not get confused note to ourselves. Cos squared x minus sine squared x. We said is cos of 2x. It's a double angle. Sine squared x plus cos squared x is 1. And sine squared minus cos squared is nothing. It's just sine squared x minus cos squared x is sine squared x. Okay, so this is the do not get confused bubble. Yeah. Okay, so how do they ask this? They ask this very much in the same way that we've been doing them with these first bunch of questions, then with the double angles, especially with this one here, question 2, and then they mix them in with reduction formula as well. Okay, so I'm going to give you a chance to start this question. Okay, so remember what we did just now with reductions. All of that applies. We have numbers here. We're not using a calculator. So all of our special angle knowledge is going to apply. And then our next new thing that's going to be mixed in here is probably going to be a double angle or a compound angle. I don't think it's going to be a compound angle because I don't see any brackets here. Okay, any questions before you start? I'm going to give you till 11:30 to finish this, 11:30. Go slowly. Let's try and get as many of these things right as we can. Start by saying which quadrant. Is my ratio positive or negative in this quadrant? Reduce it correctly and then do your special angle. Apply double angle if you need to. Okay, let's see how we do. Feel free to unmute and talk to me if you need to. Okay, let's see. I'm going to reveal the first step and then you can check if you got that. I hope you didn't get caught out by the tan negative 330. Negative 330 will be in the fourth quadrant. And tan in that quadrant is negative. Let me just fix mine. Hold on. Yeah, let me write here about the tan negative 330, an extra note. So you do the negative angle, and that will be negative tan 330. And then because you are reducing it again, because it is tan 330, it will actually be negative tan 30. Okay, so that was a little bit more difficult with the tan negative 330. And then to spot the double angle is the negative sign 70. Because it's like the odd one out, but you should notice that 35 times 2 gives me 70. So there's the double angle, sine 70. So you expand it. Who got that right? Please put a thumbs up so I can see. Who spotted that the sine 70 was actually 2 times 35? So 70 is the double angle. No, Sola. Anyone else?
Ma'am,
Yes, Nola.
I got the double angle with the sine 70, but I wanted to know why you didn't change the sign for tan.
Here for tan 30.
Yes, ma'am.
Okay, so if you see what I wrote here in the bubble, you actually, it was a bit more tricky because you have to do 2 reductions actually, because you first do the negative angle. Tan of negative 330 is negative tan 330, but then you still have to reduce the tan 330, and tan 330 is in the fourth quadrant, so it's negative, and then the 2 negatives actually make it positive. Just see what I wrote here in the bubble.
No, I just like needed you to explain it because I was like, oh, what's going on? But thanks, ma'am.
Okay, but you got the double angle, great stuff.
Yeah.
And then finally, we need that double angle because otherwise we're stuck. We can't go any further, okay? Because you're not using a calculator, so you can't do cos 35 and sine 35. 35 is not a special angle. 30 and 60 are special angles. 70, that's the key to unlock the puzzle. 70 is double angle, so you expand that, and then that's your final answer because you're gonna cancel out here. Then tan 30 is 1 over root 3, sine 60 is root 3 over 2, and the negative 2 carries from over there, and that gives you negative 1. Okay, I've got some past exam questions that we're going to practice some more, But if you didn't see that double angle expansion, then make a note for yourself. That is what you have to look out for, especially in the final, in the grade 12. Okay, guys, we are halfway through, and I think we are doing well for time. I'm gonna let's take a little break till about 22, a 5-minute break. Grab a glass of water or something to eat, or if you need a bathroom break, and then let's all get back here at about 11:40. Is that okay, Matrix? Can you give me a thumbs up, please? We are taking a break till 11:40. Thanks, Chad. Everyone else, just show me that you heard me and that you know what's going on. Excellent. Okay, see you back here in a little bit. Right, I hope everyone had a little leg stretch and maybe got a cup of coffee or tea for our final stretch of the workshop. I just had a look. We might have to decide on if we want to do equations or identities. We'll move on to past exam questions, but we'll judge the time when we get there, because we might need to just hurry up a little bit, but I also don't want to, I want to make sure that we cover what we need to cover. Okay, just send me a smiley face if you are back and ready to carry on. Hi, Rechmuditse and Saki. Yay, everyone's here. I'm also here. There we go. Okay, welcome back. Okay, can you just tell me how is it going so far? How are you finding it? Should we slow down? Should we speed up? If you can just let me know in the chat. It's going okay so far. And if you want us to speed up, tell me that part especially. Speed up or slow down, you can just put that in the chat. Are we just standing still, Matrix? Speed up or slow? Same pace. Okay, cool. Same pace. All right. Same pace. Lovely. Okay. Right. Now, we've covered our basics, got to know our reductions, special angles, all the rules around where the trig ratios are positive and negative. Then we've got our compound angles. Okay, Jaden, I'm glad to hear that. That's good. But this is the other thing with this trig. You probably only did this at the beginning of the year in term 1. So you might have forgotten a lot of it already. I hope your cheat sheet is also coming along nicely and you're making notes for yourself. Literally, if you make a good cheat sheet, you only have 1 page to study from. I'm a big fan of 1-page summaries and cheat sheets because all the information is just in one place. Okay, so like I said, we've covered our basics, the most important things we need to know. Now we're going to look more at the kind of question where you have to draw a diagram. So we've done quite a lot with the special angles. These ones are all about having to solve the question without a calculator by drawing a diagram on the Cartesian plane or not on the Cartesian plane. Okay, so there's 2 different diagram questions that you can get. And the one is, oh, maybe I should switch my pen on Cartesian plane. And not on the Cartesian plane. It's as simple as that. But for all of these, you are going to draw triangles. Now, this first question I've chosen is quite a serious question, but they do like to ask two angle questions quite often. So here we go. Cos of A is 3/5, and A is smaller than 90. And then sine of B is 12/30 and B is greater than 90. Determine the value of cos A minus B, sine A plus B. What do we see here? Compound angles. So already at this stage, if this is your exam, you grab your formula sheet, you're going to need your compound angles. This doesn't say without a calculator, but this is most definitely without a calculator. Okay. So, cos of A is 3/5. So let's start there and we make our Cartesian plane. And A is smaller than 90. If A is smaller than 90, it means it must be in the first quadrant. So you put your terminal arm, that arm that is rotating, you put it down in the first quadrant because that gives you an angle A that is less than 90. And that's going to be your first triangle on the Cartesian plane. This is your x-axis, this is your y-axis. Now, in the ratio that's given, you will get, this is cos, so this must be adjacent over hypotenuse. Adjacent hypotenuse. But because we are on the Cartesian plane, we need to work with x and r. So that's the next thing you need to do, is you need to place your sides in the correct spot. So x is 3, r is 5. This one here is y, and we are going to find that using Pythagoras. That's why these questions are called Pythagoras type questions, because you're always using Pythagoras to solve it. Okay, so let's deal with that first and say y squared is going to be 5 squared minus 3 squared. Please stop me at any point if you're not sure and if you don't understand why I'm doing something. So, because I'm going to go through this part a bit quicker, okay. So 25 minus 9 is 16, so y is 4. Okay, so this one here is 4. Okay, that sorts out that triangle. But we've got another one to draw for sine B. Okay, so I think that could possibly be a confusing thing, is realizing that you have to draw 2 triangles. You can't draw a triangle for where angle A and angle B is represented. Okay, you have to draw 2 different triangles. So we're going to rotate further along, because now this says B is bigger than 90. Okay, well, B is bigger than 90 in this quadrant, in this quadrant, in this quadrant. In all those quadrants, you'll have an angle greater than 90. So we need some other way to decide what quadrant to draw in. And that lies in this here, because 12/13 is positive. In which quadrant is sine positive? Of the remaining 3 quadrants, it's only in the second quadrant that it is positive. So that's where you're going to put down your arm. Okay, and this is angle B. Okay, so angle B isn't here. Angle B, you are always rotating right around. So angle B starts from the x-axis coming around. Like I've explained the whole thing about rotating in the anti-clockwise direction. Okay. Drop the perpendicular. Perpendicular is always with the x. We never make perpendiculars with the y-axis, okay? It's always with the x. So you never end up with, for instance, something that looks like this. Okay, that's wrong. It's always with the x. Okay, next part, put my sides in place. What's given here is opposite over hypotenuse, but we are on the Cartesian plane, so we need to talk in x, y, r language, and that is y over r. So my y is going to be 12 and my r is going to be 13, which leaves me my x to calculate. Same story now. X squared is going to be 13 squared minus 12 squared. I get my x squared is 25. So x is 5, but I'm on the Cartesian plane, so I always need to bear in mind that there are signs, positives and negatives. So this must be -5. And there are my two diagrams. Okay. How's it so far? Are there any questions? I'm going to stop quickly for a question if you're not sure how we got to somewhere. So it's always the same. Choose your quadrant, place your sides, find the other side using Pythagoras. Now we're going to answer our question. Cos A minus B. So cos of A minus B is going to be cos of A, cos B. So here you just go to your formula sheet, right? You just grab the formula for the compound angle, but you got to obviously realize that this is the compound angle. So compound angle formula, and this is sine A, sine B. Cos A, cos B, sine A, sine B. Yes. No, plus. Okay. You see how easy it is to make a mistake. Double check, guys. Always double check. So that means I need cos of A. Cos of A was given as 3/5. Cos of B. Cos of B is adjacent over hypotenuse in the blue triangle. So that's going to be -5/13. Adjacent over x over y. Yes. And then sine A is sine of A is opposite over hypotenuse, so that's 4/5. And then sine of B was given as 12/13. Okay, still no calculator. Okay. Regemodel 12 is not negative because it is on the vertical, on the positive side of the y's, if that makes sense. It's just the x that's negative because it's on the negative side of the x-axis, but the 12 is still on the positive side of the y's. Okay, so negative 3 times -5 is -15, and then 5 times 13. So you can use your calculator to do a little bit of calculation, okay? But you can't just from here go straight to answer, because then whoever's marking is going to know that you used your calculator when it said no calculator. So you can go, what is 3/5 times -5/13? Oh, that's 65. And then what is 4/5 times 12? So 4 times 12 is 48. 48 over 65. And then 48 minus, that is 33 over 65. Okay. Right. That's what I get. Any questions so far? Cos A, cos B, sine A, plus sine A, sine B. Our cos of A is adjacent over hypotenuse. Then we go to purple triangle. Cos of B is adjacent over hypotenuse, -5/13. Sine of A is opposite over hypotenuse, so that's 4/5. And then sine of B was given as 12/13. Simplify, sneaky use of calculator, but never ever just go to answer. Okay, I want you to now do the next one, which is sine A plus B. We're still using the same diagram, same angles. We're just doing sine A plus B now. On your own, please. No, Timothy, they won't. They'll just subtract that 1 mark. And they'll also only penalize you once. So you're obviously going to use that -5 now again for sine A plus B. No, you won't actually. But say you had to use it again, they're not going to penalize you every time you use it, if that makes sense. They penalize you once and that's it. It would be a bit mean if they penalized you every time. Right, okay, everybody, did we get that final answer, 16/65? Maybe we can hear from the live stream, Tula. If you're on the live stream and you get 16/65, give us a thumbs up. Excellent, well done. Great. Okay, so that's a Cartesian plane question with everything thrown in there with the compound angles. Now we're gonna, so that was the first type. Now let's have a look at the other one, which is often the one that people find a bit more difficult. So if cos 18 is equal to k, express the following in terms of k. Again, no calculator. Okay, so the first thing we're going to do is we're going to make a diagram. If you can't use a calculator, you have to use a diagram. So okay, let me do this over here. Now we're not drawing on the Cartesian plane. If you do end up drawing on making a Cartesian plane and drawing it, it's not the end of the world. But this is generally just a little triangle like this. And this is my 18 degrees. Put it over there or over there, it doesn't matter. And that's my 90 degrees. So cos of 18 is k over 1. So here we have adjacent hypotenuse. So hypotenuse, the longest side is going to be 1, and the adjacent side is going to be k. And this third side we will work out. We are going to work it out. It is using Pythagoras. So in this case, what can we call it? I'm just going to call it, I don't want to throw another variable in here. I'm just going to make it a question mark, that one. So that unknown side is going to be 1 squared. Actually, I'm going to have to give it a, let's call it, let's make it m. It's unknown. We're going to give it a value now. So m squared is 1 squared minus k squared. And that is obviously just 1 minus k squared. But because we just want m, this is 1 minus k squared. Okay, so the part where people sometimes get this wrong is when they take the square root. And they take the square root of the 1 and the square root of the k, and they say that the side is 1 minus k. But you can't just take the square root of each individual term. That's breaking the rules of taking square roots. When you take a square root, you take the square root of the whole side. So this side is in fact root 1 minus k squared. Let's also fill in this angle here. That angle there will be 90. So it's 180 minus 90 minus 18 because of interior angle of triangle, 72 degrees. Right. Now we can start with the questions. So the first question says, sine of 18. Okay, well, that's easy. That's just going to be opposite over hypotenuse. I'm just going to rub some of this out here. Okay, so write down what sine of this angle is going to be. Sine of 18. Write that down. And then we're going to check if you're correct. Okay, so there's the, you should get 1 minus k squared. So it's opposite over hypotenuse, but because it's over 1, you can write the over 1, or you can leave it out. Okay, now cos of 162. Where is this 162 coming from? Because we don't see it in our triangle. But it's also not an acute angle. So maybe if we go 162, 180 minus 162 will give me 18. So this is going to be, so you basically reduce it. 180 minus 18 will be 162. Cos in the third quadrant, because 180 minus is the third quadrant, cos of the third quadrant is going to be negative. So this reduces to negative cos 18. And that's just negative k then. There we go. So you kind of have to look for clues and like relationships between the angles. Like the 108 now, tan of 108. Where is that going to come in? Because we don't have 108 in our sketch, so we somehow have to make a plan, figure something out. How are we going to get the 108 to relate to the 18 or the 72 so that we can use our triangle? So 108, that is in the second quadrant. Most of the time when you do reductions, these work very well. So 108 is in the second quadrant. Whoops. And what do I have to subtract from 180 to get 108? 72. So this actually reduces to tan 108 reduces to tan 72 degrees. And it's negative because 108 is in the second quadrant and tan is negative. Where's 72? It's over there. So if we do tan of 72, it's opposite over adjacent. So then it's this over that. Did all of that make sense? Please stop me if you're not sure. Put it in the chat. Okay. Okay, so tan 108, 108, second quadrant, reduce it to tan 72. 72 is in my triangle, yay. So it's going to be negative k over root 1 minus k squared. Cos of negative 36. Oh, negative 36. How are we going to solve this one? What do you notice about 36 and 18? 18, twice 18 is going to give you 36. So 36 is a double angle. But first, we need to do cos of a negative angle. Negative 36 is in the fourth quadrant. So cos in that quadrant is actually positive. So this is going to reduce to cos 36 first. Then cos 36 is 2 times 18. So there's my double angle. So now you can do any one of the expansions for cos. I'd probably just do the one that says 2 cos squared x minus. I think that one, because you already have cos. So you've got that one. There we go. 36 is 2 times 18. And now you just have to make it 2k squared minus 1, because cos 18 was k, so you just sub it in. Okay, I think last year they asked a similar question to this. And the year before, good chances it will come up again. But there will be either Cartesian plane diagram or this type of diagram to answer. Okay. Right. Let's move on. Any questions here before we move on? Cos of 162 was minus k, Benedict. So minus cos 18 was minus k. Cos of 36, of negative 36, 36 is in the fourth quadrant, or negative 36. Remember when we rotate with negative angles, we were rotating this way. So for negative 36, we're going to land up somewhere in the fourth quadrant. And in the fourth quadrant, cos is positive. So that's why it's not negative cos 36. It's cos 36. Hope that makes sense. Okay. Okay, guys, can we move on from these sketches and these diagrams? Any questions? Okay. Last chance. Okay. Time to tackle some identities, I think. By the way, this is normally the sketch with Pythagoras is normally like the first or the second question on the paper. Okay, let's do some identities. And here are some tips for you when you do identities. I know sometimes it can be really unpleasant, especially if you can't get the two sides equal and you start panicking. But they really just take some practice. Okay, so when we do an identity, so this question normally says, prove that. I left that out. Prove that. Okay, we're going to do 1, 2. Prove that sine 2 theta blah 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 is equal to right hand side blah blah blah. So you take the side, this is your identity, okay? How do you know it's the identity? Because you have to prove. You have to prove that this thing is the same as that thing. So we're going to split the left-hand side and the right-hand side. And you're going to work with the side that is the more complicated side, obviously. So if we can look at our first question, that's the left-hand side. If we look at the second question, that's also the left-hand side. Sometimes you have to work with the one side a little bit until you can't anymore, and then work with the other side until you can actually prove them equal. But that doesn't often happen in the final exam, okay? So the identity, this is the one we've come across earlier this morning. Tan theta is sine theta over cos theta. So we're going to split left-hand side and right-hand side. Where you see tan, change it to sine theta over cos theta. Then you look for your double angle. Sometimes there's a compound angle. When it's a really difficult identity, there might be a compound angle. But the double angle pitches up all the time. Addition and subtraction of fractions. Now you can see, and if you look at your past papers, there's a lot of these identities with fractions. And that's why I've chosen these two for us today as well. You need to find the LCD and simplify. Okay, we're going to do that now if you've forgotten. And then factorize or use the identity sine squared plus cos squared is equal to 1. Okay. So you need to bring in all your knowledge of double angles, all your knowledge of fractions. You must know that tan is sine theta over cos theta. And then you must know that sine squared plus cos squared is 1. But also, we can rearrange this sine squared plus cos squared equal to 1 in different ways. We can get cos by itself, 1 minus sine squared. Okay, that works too. It's a version of that identity. We're just moving the sign to the other side. Similarly, sine squared theta is 1 minus cos squared theta. Okay, so it works those ways as well. Right, let's get cracking. I'm going to do this first one with you, and then we're going to see if we can attempt the other one on our own. Okay, remember you are working on a mark a minute. In paper 2, you have to really stick to that because the time pressure in paper 2 is much higher than in paper 1. So if you see an identity and it's 6 marks and you start working on it, and after 5 or 6 minutes, it's not going anywhere, walk away. Okay, it's like that boyfriend or girlfriend that's not treating you nicely. You just walk away after a certain amount of time, okay? Just walk away. So sine 2 theta is 2 sine theta cos theta. Right, cos theta. Sine theta. Double angle, we expand straight away. Now we've got the cos double angle here as well. And that's got 3 options. I think we must maybe just try and stick with having sine at the bottom. So let's use the cos double angle formula where we're just going to end up with sine, and that is 1 minus 2 sine squared theta. Okay, I might be wrong here. I don't know. I might regret this and having to go back and change my mind. Okay, I don't know. We're going to see. We are going to see. And that's the thing with identity. Sometimes you try something and it doesn't work. You just keep trying until the time comes. You see, it's like that relationship. Until the time comes where you can't try anymore and you just have to go. Okay. Whew. There's lots happening here. So what are we going to do at the top? We are going to, let's take out a cos theta. 2 sine theta minus 1. It's fine if you just want to listen for this one, and then we'll tackle the next one. Okay, right. What do we notice here at the bottom? If I put everything nicely in order, what am I going to get? What is it? What is that thing called? You can put it in the chat if you know. Anyone spotted what it is? Any guesses? Okay, if I then said that thing is the same as this thing, what is that?
A trinomial.
That's it. Trinomial. So this is a trinomial, but just with trig terms. If this is hard for you to do, 2 sine squared theta plus sine theta minus 1, you can do it like this and then just go back and replace the x's with the sine. Okay. But I don't want to confuse you by doing it like that and then maybe, yeah, we'll see. Let's carry on. Let's see. So now we need the factors of 2 and the factors of -1, and that's going to be 2 sine theta minus plus 1 sine theta minus 1. No, that's plus. This must be minus. Okay, so that was a good choice to have made, to have kept everything with sine at the bottom, because now we can go like this and say this cancels with that, and I'm left with cos theta over sine theta plus 1. And that's the same as what I've got here. And that equals the left-hand side. Okay, so things to watch out for. Double angles, number 1. Factorizing. We factorized over here. Try and keep everything in terms of sine and cos, and keeping all sines and coses in the same place. And here we factorized again, trinomial. They love asking trig trinomials in the final exam. There's lots of them. And like I say, if you get confused by it, then you can just replace your sines and causes with x's. Okay, any other questions? Because this next one you're going to tackle on your own now. Okay, these normally take a while to do, so I'm going to give you 4 minutes, 5 minutes. I want to see everyone give it their best shot for question 2. And unmute if you want to speak to me. Start with the left-hand side. Oh, I didn't even write that. I should have written it here, left-hand side. Okay, start with question 2. And if you are stuck and you have a question, please ask me. Right, guys, I've put the working up for question 2. Cos 2x. Is cos 2x minus 1 the same as 1 minus 2 cos x? No, that is not the same thing. Cos 2x is the double angle, so you have to use the one of the double angle rules for it. And the double angle rule says 2 cos squared x minus 1 is the same as cos 2x. Does that answer your question, Timothy? Okay, so I hope you did the expansion for sine 2x, 2 sine x cos x. And then I hope maybe you chose a different option here. It probably meant that you had to go back and relook. I don't know if anyone tried something different, but still got to the answer. And then here we factorize the top, and then we factorize the bottom as well. And we get that happy bracket over there. That's the same. And we get sine x over cos x, which is tan x, which is what we want. Okay, can I see how many of you got all of it, or even just some of it? Just some of it or all of it? If you got all of it, please share with us that you got it all right. But even if you just got some of it, that's amazing too. Some of it. Nice, Sola. And Saki, some of it. Good.
It's a positive half.
Say again, Saki. All of it. Nice, Regmuditswe. Good stuff. Okay. Last part is our equations. Yeah, so sorry, just to come back to our identities here, guys, this is probably what you can expect. Having to use your double angles and having these fractions to work with, lots of factorizing and trinomials. So if you've got a textbook, just do some questions from your textbooks. Most of these matric textbooks are very good and they've got good questions in them. Otherwise, you can also, if it's possible, do your, what's it called? Like a study guide. If you need to get a study guide, that's also useful. Yeah, but just practice your identities. But do you see, we can't really do identities unless we understand our double angles and our compound angles and our reductions and all of that stuff. Because if you don't have all of that solid, the identities are sometimes difficult. Okay, last bit. And again, before we can do equations, all the other things must be in place. Now, these are the 5 types of general solution equations that you get. And I got this from a little study guide book, and I thought it was really useful. So first of all, in grade 10, you get the type of equation where it's just the trig ratio equals to a number. And all you do is you put that into your calculator and you get an angle. Okay. If you have a sine and a cos on both sides, on either side of the equation, the only way to solve that equation is by making tan. And for this particular example in question 2 here, we will make tan by dividing by cos. Because if you now remember from your identities, tan is sine over cos. So, and I call that make tan. make tan. Okay, so one of your blocks on your one-page summary should most certainly be dedicated to all of these trig equations. Now, have a careful look between 2 and 3 because both of them have sine and cos. In the one, we make tan. In the other one, we use cofunctions. How do we know when to do what? It depends on the angle. So if the angles are different, then we need to use a cofunction, the cofunction rule, to make it all sine or all cos. If the angles are the same, like it is in number 2, then you can divide by cos and create a tan or make a tan. So what if you have, then our fourth example, cos x equal to cos x plus 30. No numbers, just ratios, but the ratios are the same. Here you're going to go to your reference angle straight away. So, and that's when you have no numbers in front of sine, cos, or tan, only cos or tan or sine on both sides. And then if you don't see number 1 to 4, so just simple sine theta is a number, sine and cos angles the same, sine and cos angles different, same ratio, different angles. If you don't see any of those 4, you have to use an identity and factorize. And most of the time, you'll get a trinomial. Okay. Right. You can definitely take this down if you feel this is useful. I'm going to start by just doing a simple grade 11 general solution question, just to get our minds working and refreshed. What is general solution again, and where does it fit in, and where does it fit in? Sometimes they'll say just it's a standalone question, but most of the time you will find general solution with graphs. General solution and graphs go hand in hand. Trig graphs. And why is that? Because when you are doing general solution, or when you're solving a trig equation, you are actually finding the points of intersection of the graph, of the graphs. Okay, so general solution, find the general solution of 2 cos theta is equal to 0.6. So that's fairly easy, but it's just to get our minds into this particular section. So 2 cos theta is 0.6. Definitely fits into this first type. Sine theta equal number. We just have to divide by the 2 to get it the same, to get the cos by itself. So if I do that, then I go 0.6 divided by 2, and that is 0.3. Now I'm going to go to my calculator and find the reference angle. The reference angle is the first place where cos is the first angle for which the cos is 0.3. So shift cos 0.3. Just do that on your calculator with me, please, so that you can practice your calculator usage. So shift cos 0.3 gives me theta is 72,54 degrees. But this is asking for general solution. So you have to find all the quadrants and all the places where cos is going to be 0.3. All the angles for which cos is 0.3. Because we've seen now, as we rotate, it can happen in more than one place. So now you think, the next question you say is, where is cos positive? Cos is positive in the first quadrant. I'm going to do a little Cartesian plane on the side here, in the first quadrant and in the fourth quadrant. So your first quadrant solution is always just the angle plus k times 360. It's also positive in the fourth quadrant. So theta is 360 minus 72.54. See, here's your quadrant, this the 360 minus quadrant. So you subtract the 72 from it. That's 287.46 plus k times 360, where k is an integer. So k can be any integer. Maybe your teacher taught you n, that's fine as well. But you have to put down this whole thing with the k or the n. It's not worth a mark, but they take away a mark if you don't do it. Okay, how are we doing with this, grade 12s? Can I just get some thumbs up? I know it has been a few hours now, so maybe we're all feeling a bit tired now, but can I just see if we're good with the basic idea of the general solution? Good, okay. Right, so that was back in grade 11 when you did general solution like that. It's probably not going to look like that at the end of this year. It will probably look a little bit more something like this. I think what I'm going to do, I'm not going to do that one. I'm going to do this one. Yeah, let's do this one. Let's chuck that one. Okay. Okay, so this is also past paper questions. So actually, let me see. Decide which one we want to do here. No, let's do this one. Let's tackle this one. Okay. So we've got sine 2x minus sine x plus 2 sine squared x minus cos x. Okay. Well, the first thing I notice is the sine 2x, right? That we're going to change to 2 sine x cos x. It's a double angle. Okay, so now we're kind of stuck here with all these terms. And I think what we should do, so we're in this realm here, hey? Question type 5. We don't see anything like 1, 2, 3, and 4, nothing too simple. So we need to use our identities and we need to factorize. So we've used our identities already. We can't really do more than that. So what I'm going to do, what I'm thinking is grouping terms together so that we can factorize. So I'm going to put 2 sine x cos x with the minus cos x and the plus 2 sine squared x with the minus sine x. I'm grouping them so that I can factorize. So I'm going to take out a cos as a common factor, cos of x, from these first two terms, from these two. Let me get my highlighter. So I'm going to group these two together and those two together. So that gives me 2 sine x minus 1 in this first bracket. And then here I'm going to take out a sine x. And then it's 2 sine x minus 1. Okay. And now we've got a common bracket that we can take out. Let me get my highlighter again. This here and this here. It's the same. Okay. Right. I'm going to split my brackets. I'm going to say 2 sine x minus 1 is equal to 0. And then cos x plus sine x is equal to 0. On this side, I'm going to take the 1 over to the other side and divide by 2. So that gives me sine x is equal to a half. And then I'm going to take the sine x over to the other side. Okay, so now I've got something on this side that looks like this first type of equation, right? It's just sine theta equal to a number. So sine x equal to a number. On this side, I've got cos x and sine x. So that takes me to here, sine theta, cos theta. Let's make a tan. And we can make tan because the angles are the same. So this is 1 is equal to negative tan x. And then tan x is equal to negative 1. Okay, sure. We've done all of that. And now we can do our general solution. And we can only do the general solution for, I'm going to do it like this. I'm going to save some time by just putting this up so that you can see. Okay, so tan is negative 1. So we'll do reference angle on this side. Let's go through the whole process. They've skipped a few steps here. So reference angle for sine x equal to a half is shift sine 0.5 30. And for tan x, the reference angle is going to be 45. So you just go shift tan 1, not negative 1 on your calculator. Okay, I hope you learned that when you were doing general solution, so that you never put the negative number into your calculator. Okay, always just positive. So that gives you 45. In which quadrants are sine positive? That's in the first and the second. So here's my 2 solutions. This is for the first quadrant and the second quadrant. And then this one for tan, also, remember you only do one general solution for tan. And tan is negative here, so that is in the the third or the fourth quadrant, but you only need to do one. So remember that always put the positive number in your calculator to find reference angle. and only do one solution for tan. And the reason for that is because you'll see if you actually carry on doing solutions, you just get the same thing. Only one. Okie dokes. Okay, that was quite a long question, quite a lot. It is a past exam question, and I didn't want us to just do easy things. We must try and do hard things as well. But we haven't just done easy things today. We have done quite a few hard things too, so that's good. Okay. I don't feel too bad about not going through these extra past exam questions I picked out for you, because I feel like we did most of it already, and I don't think you'll really learn anything new. I think the first round of questions we did as we were going section by section. Those questions are of a really good level and very indicative of what you can expect in the exam. So, yeah, that's it from my side, I think. We've got a few more minutes, so if there is anyone who still wants to grab the opportunity to ask a question about trigonometry, please go for it now. Or if you have questions about what we just did with this general solution, also please fire away. Is there anything, Matrix? Okay, so yeah, I hope I've given you enough tips and enough to work with to get through this section, and to maybe go from the 2 out of 10 you gave me at the beginning to a little bit more than that. So trig is big. It's between 40 and 50 marks. So it's about a third of your paper, but that includes everything, not just what we did today. What we didn't do today was the trig graphs and the 2D trig and the 3D trig. So it's all of it together gives you about 40 to 50 marks. So it really is. We probably covered about, if it's about 40 marks, we probably covered about 2/3 of that today, because your general solution comes in with your trig graph. Yeah. But Timothy, I think some of you were around last term when we did 2D and 3D trig, and we revised all of that as well. So, yeah. Great. Anyone else have a question? Okay, well done, Matrix. Well done for pitching today and giving 3 hours of your Saturday and committing to this. And I really, really wish you well. You still have about a week or 2 left with some of our other teachers. I won't see you again. I'm not teaching you guys again. So from my side, just all the best. And I really, really hope this goes well for you. Tula, over to you.
Hello, grade 12s. How are you guys doing? My name is Tula. I'm a mentor with Watobe Maths. So a lot of you will be familiar with Coco, who is usually sort of the administrator for these lessons, but I'm just going to take you for today and quickly share my screen to show something to you guys. So first of all, thank you very much, Mary-Lise, for the wonderful lesson. I hope it was really fruitful for you guys and you feel better preparing for your finals. I'm just going to share my screen. If you can't see, of course, just let us know so we see what we can do to help you about that. It should be up in a second. Yeah, so I'm going to show you a few dates that you should diarize just for the next few lessons that are coming up. We still have, I think, 2 quite a few actually that are coming, the revision lessons. And remember, we want to always remind you to tell a friend. If you find this valuable and you think they're helping you, chances are a friend will also find them valuable and will also be helpful to them. So have them go to the Watobe website and just sign up for our classes so they can join us, and they will hopefully also find value. So this is where we are today. It's the 23rd of October. We just finished with this particular revision. And then we also have, so the next one we have is on the 25th, which is Monday, which is 5 p.m. We'll be doing geometry paper 2, and then following up on the 27th of October, 5 p.m. as well, geometry paper 2. I think all of you at this point are subscribed for the notifications, so you do have these notifications on your WhatsApp. So remember to always just double check that. I think we also send a reminder about an hour before on that day. So it should be very hard to miss, and you can always go check out our website. And then on the 30th of October as well, you can take a screenshot of this, or you can write them down. Just make sure that you have these dates in mind and you always know where to find them. For those of you who are new, who maybe have missed some of these previous lessons, you can always go to watobe.co.za on live lessons and then go to grade 12s, and all these classes are recorded. So you can always access previous classes and you can use them for your revision. You can go through the exercises that are being done there. We always want you to be live so you can ask questions and interact, but it's the next best thing. You know, if you happen to not be here, we don't want you to miss out. And you can always go to the app as well. On the Watobe app, go to Trigonometry and just do what you can. There are quizzes there, there are lessons. Just put your best foot forward and do what you can on your side. And more often than not, that will be rewarded with good results, and just you'll definitely see a difference. So I think you guys have had a pretty long morning, so I'm going to let you go. I'll stop sharing. That's it from my side. Does anyone have any question, any comment, any confusion? If you get questions later on, you can always just send a message to us on WhatsApp or on the chat on the Watobe app, and we'll always be on the other side, just within reasonable time to respond to you. So yeah, that's it from me, grade 12s. Thank you for the wonderful lesson, Marilise, and enjoy the rest of your weekend, guys. See you on Monday.
Bye, guys. Enjoy.
Bye.
Bye.